Okay, now we're going to talk about the MOS, metal oxide semiconductor transistors. First, the behavior and the current equations. So the transistor, MOS transistor, looks like this. It's a P substrate, and you have N-type wells, and on an oxide layer you have your gate, source and drain. So what happens here is that when you apply a voltage to gate, you attract the electrons here and create an inversion layer, and you have a current. Basically, you create a bridge here, or we call it a channel, and you can now conduct the current from here to there. And the transistor would look like this. This is your gate, this is your drain, and this is your source. Because there is an oxide layer, there is no gate current, and all the drain current would be equal to the source current. And the behavior would be the drain current. If you increase your gate source voltage, first you wouldn't get any current, and then you start suddenly gaining a current in exponential. And this part, we would call it the threshold voltage. In terms of the ID versus VDS, if we increase, provided that the transistor is on, the smaller the drain source voltages, the current would increase linearly and then reach to some sort of a saturation. So we call this triode region, and this region saturation region. So in triode region, you would have the VGS minus VTH. We also call this overdrive voltage. Would be bigger than drain source voltage. Here you would have the current, you would have the VGS minus VTH smaller than VDS, so we have a larger VDS. And the current equation for the triode region would be a function of not only transistors gate source voltage, but also drain source voltage. So drain source and also gate source voltage. W over L are your transistor's dimensions, width and length, and this is process specific parameters. So in saturation, you would have mostly the VGS dependence, so there's not much drain source voltage dependence. However, just like the NPN transistor, we have a parameter here, this lambda, that comes from, that's called the channel length modulation, that affects the transistor's behavior and adds as a drain source voltage dependence.